Good evening, YouTubers. Welcome to episode 57 of Shrigleytubetv. Thanks for returning. If you're a returning viewer, if you're new to the channel, then welcome. I hope you like what you see. Not a great deal happened this week, to be honest. 20 minutes of work, that's about it on the video tonight. I did manage to get the 998 and the Dyno and ran. That's all good. And we've been turning some liners, so been absorbed with that. And getting back into the swing of things after a little break with National Weekend last week. So it's all good. I'll get more together and something interesting for next week. But for this week, I hope you enjoy what you see, and I look forward to seeing you next Sunday at 7. Have a great week. Bye for now. Good morning, YouTubers. Welcome back to Shrigleytubetv. It's all over. National Weekend's been and gone for another year, so we're getting stuck back into some work. Now, you might recall last week I had this engine in pieces. It was an engine that had been brought to me with a smoking issue. He didn't want it rebuilding because it had good oil pressure, etc. It was a 998 with an R20 camshaft. I've just gone in there. Basically, the bearings are all them lovely original Van der Velde bearings, so I've left them. The crank mic'd up great. The head was good. Just put a set of valves in it because they were quite old, the ones that were in it. We've also matched the inlet ports because it was on, I think it was on Stromberg's before, so it's got a nice combined manifold now. So I've just done a bit of port matching. But what I was making the video for was when I actually got involved with it and looked at it, and I thought it was quite nice, the bottom end. It's a GB020, which means it's a George Bevan engine, so quite nice. Anyway, we're going to run that up hopefully tomorrow or before Sunday, so you can see it on the dyno and get a tune out of it. But the chap provided some Dyno carburetors, my favourites, to run it with, and I've come to take them apart, and you can see they're really khaki. I've actually burst the head of the screw there trying to undo that. Now, normally we put them in the ultrasonic cleaner with a type of cleaning fluid that's recommended for the ultrasonic cleaner. Now, it's a water-based fluid, which I'm not too keen on because obviously I'm not stripping the carbs right down, so some moisture gets in behind here and into the bearings and stuff, and then I have to dry them out on the top of the heater so the moisture disappears. But a chap said to me, why don't you run your ultrasonic bath with some kerosene? So I'm just pumping some more out of the tank next door because we have it for our heating oil here. So I've got this on the heat cycle, so at 27 degrees, pure kerosene. So it's a bit of a learn for me, but if this cleans the carbs, it'll be much better for cleaning them than using the proper ultrasonic cleaner, which is obviously water based. So we'll put all these bits in the tray that's down here, and I'll report back shortly and let you know whether it's worked or not. Okay, we've got everything in the tank of kerosene now. We're at 24-25 degrees kerosene temperature. Not sure how high I want to go with the diesel temperature because obviously it gives off a lot of vapor, and also it could be a flammable issue. So yeah, we'll see what happens. I'll press the button now, and yeah, I hope this doesn't go bang in any strange way. See what happens. Lots of bubbles. You can see my little plastic tray there with all of my brass bits in, you know, all the parts that go inside the carburetor. So we keep all them contained in there so I can rinse them easier. Right, well, it looks to be quite happy. I suppose if the fluid turns a brownish colour, we know it's taken the oxidisation off the carburetors. Okay, we'll leave it at that, and we'll come back to it in a bit. Okay, the temperature's up to 67 degrees. The water's gone murky, so I assume that means that not the water, the kerosene has gone murky. So I'm hoping that the muck has come out of the carburetors and the carbs will be nice and clean. I'm going to lift the cage, the tray out now, and place it in this aluminium tray so that it can drain, and then we can obviously put the excess back in the tank, because it's quite an expensive way of cleaning the carburetors, especially if we're losing that fluid every time. Okay, well, it looks a lot better than it did. Looking at this, what we'll do is we'll give it a right good steam clean next. But where's the bottoms that were particularly bad? Here. It's not got it all. It's better. That one's looking a lot better. The jets are looking okay. Yeah, I think it's done a fairly good job. We'll carry on with the cleaning process. We'll get the acid on them next, and then we'll give them a steam out, and we'll have a reassess then. But for now, while we've got the machine hot, I've got this new old stock crankshaft in like a wax. I thought, oh, that'd be ideal to put into the tank and hopefully see if it comes out a bit shinier, a bit nicer. My fear is that the rust will be underneath the wax. I've seen it before where they look brand new, and then when you clean them, the journals are all rusty. Good morning, YouTubers. I thought we'd do a small video, not a full length one on how to rebuild carbs, because we have covered this before. But I've got these clean now, given them all a good steam, quite happy with them. Got all the internal parts there. Just wanted to say these are all the O-rings, etc. that come with the kit. New diaphragm. There's also a new needle valve in there as well. So what I'm going to do is I'm going to put all this into the carburetors, and hopefully we'll get a tune out of it at some point later today. I was going to say the kit I'm using is a Cytec SKD22101, which is for your Weber 40, 45 and 48. So it comes with a needle valve, etc. These are available from the Green Spark Plug website if you want one, if you fancy doing your carbs. There's my rusty crankshaft as predicted. Once it came out of the ultrasonic cleaner, you can just see a few pitting marks. I'm going to give that a polish later, and hopefully it'll be serviceable, because obviously being brand new, it's on top limit everywhere. It's a nice size. Right, I'm going to crack on with these carbs and I'll report back later. Right, we're about to run with the 998 that's had the autos cleaned, so they're all on there now and running. It runs absolutely sweet as a nut. Well happy with them carbs. I'm sure customer will be too. The smoking issue has disappeared now due to sorting out the new pistons, and put some valves in it as well, and did a bit of port matching. Just to give you an idea before I run it, it's an R20 998. It's that old school George Bevan block. So I won't go on too long. I'll just say, yep, I've done a bit of running today. It seems quite happy. We're not going to go crazy on it because it's still pretty fresh, so we're just going to give it a bit of a wind up, and then we'll call it in the out tray. And it's going to have a new cam cover painted black, and we're going to give it a steam clean as well, make it look a bit prettier for him. Okay, I'm on the dyno now with the 998 with the carbs we've just refreshed, and it's had some pistons in it and some inlet valves, exhaust valves, and we've done a bit of port matching, and that's about it. New set of wheels rings. It's had the oil leak fixed on the sump, so we're just going to run him up and see what he's got. It's quite a good air day today. It's about 1025 millibars, so we're seeing quite good figures out of it. It's not a particularly high compression engine, and it is on sport size valves, but it all seems to complement itself quite well. The R20 cam, the moderate compression, the ports are quite nice. It's a Chessman head. Obviously it hasn't got a block strengthening kit on it, or like big end bolts or anything, so although I did inspect the crank and everything, and it's belted, it's got like Van der Velde bearings, original ones in lead copper ones, so we'll leave them be. So the oil pressure's good, it runs really well. The carbs have turned out really good, they pick up beautifully. I put 30mm chokes in them to keep the airspeed up, and it just, even if I load it up, I can go wide open at like 2000 RPM. Just pulls it straight through, which will make it a nice drive, because I know the bloke that owns this car, and I know what he's going to do with it and how he's going to drive it. So we're not going to go for big horsepower figures, but we'll load it up. So at 4,000 there, it's got about 68 foot-pound. Just back the dyno up a little bit. So 5,000. Gone up again, it's about 73. We'll undo the dyno now. So 6,000. Still holding 70 foot-pound at 7 there, so we'll do a little calculation in a minute and find out. But I think it's probably roughly about 80 horsepower, which is what I'd expect from it. So brilliant. We'll call this in the out tray, get his cam cover painted, and get on with the next job. Right, okay, it's time to get my teeth sank into some proper engineering now. So this is a liner that I've bought from Westwood Liners to fit inside this 1200cc long rodded, long stroke cranked race engine from doing for a chap, and I want to get this try and get this ready for September in the out tray. So it's having all sorts of fancy fuel injection on it, and it's going to be a pretty top level engine, but with a milder cam because it's aimed for the hill. So we want it to have some mid-range torque. It's not going to be all about the peak horsepower on this one. But anyway, that's another story. We'll come to that when we come to dyno it. So it's a dry liner block, so the liner's fully supported. We've got to machine this liner so that it goes inside this block, and then we'll warm the block up, drop it in, etc. But I'll do all that separately. Now on the lathe here, what I wanted to talk about was I want to machine this liner. Now when you machine a liner, if you put it in a free jaw chuck, the pressure from clamping it, whether it's internally or externally, it basically triangulates the end of the iron, because you wouldn't think it'd move, but trust me, it moves, especially with the clamping force required to drive it. So what I like to do is, that this has been done many a time before, you can see on this piece of aluminium, is I put the aluminium in the jaws, tighten it up nice and tight, and then I machine it so that I've got an index, so that what I'm going to do basically is I'm going to offer this onto here, so that sits on there. I've got another one here which is an imp water pump pulley that goes in this end, and then I'll just pause and I'll set it all up and I'll show you what I mean. Okay, so we've got the liner in the lathe now, and I've got it in the index there, so it's fully supported by the aluminium and it's hard against the shoulder. Now the load is being transferred from here, so this is pushing this way, and these are the locks. This lock locks the saddle to the or the tailstock, sorry, to the bed, and then this lock locks this one. So anyway, yeah, I've locked it all up. So these are all pushing through what we call a revolving centre. So this has got a bearing inside it. If I knock it into neutral, you'll see the bearing spins inside the revolving centre there, and then it's in turn, this index that I've machined in the end of this imp water pump pulley is sat in the top of the liner. So the theory is that the liner isn't in a stress state. It's not triangulated this end, it's not waving around this end, it's fully supported. So when we machine it, it'll just machine dead nice. In fact, if we fire it up, it should be absolutely like thou perfect. So you see it's nice and true. So my first operation is to part this liner off to the correct length, because it's a bit long at the moment. Now we have to buy these long liners because it's a long stroke imp engine. The standard imp liner, we can machine the standard imp liner, but it isn't long enough, obviously with it being on a 70mm stroke. So we're going to make a long liner for it, and then we'll turn it and then warm the block up, drop him in, clamp him all up. There's still quite a bit of machine work. I've only machined the water gallery for one of them so far, because I was going to do them all, but I thought, hang on, what we'll do is we'll get the crank in it. I've done all the measurements, but we'll get a dry build on and we'll see where it all sits, because I like to just see how everything's going to be before I get too carried away, finish machining, and then we'll do all the skim it, deck it, blah de blah, do all the machine work to make it correct. Okay, it's time to part the liners to length. So I've selected quite a slow speed, which is 125 revolutions per minute. That's obviously 125 times it goes round in a minute, and I've named each. It's not the name of the liner. It's not called Peter and Noel. It's just that's the job that they're being allocated to. So just keeps it all simple in my head if it's written on. So this is going to be a 1040cc imp with a normal length liner, and this is the long rodded liner with the extra stroke as well. So what I've done is I've worked out that I'm basically about 4.5mm into the depth on each side, and then I'll be breaking through at 5mm, so 10mm overall loss in diameter. But what I've done is I've made a stop on here about 20 thou off full depth, because if you remember before, we're not driving off the jaws are just holding the aluminium. So the drive is coming from the friction from the load being put on by this screw thread here, which is pushing the revolving centre against that, pushing the job up against the boss. So what happens is, if we break through to full depth, all of a sudden the load squashes the tool, it pings out of the lathe, it all ends up scrap, and we have to buy more liners. So work it out first, so you can laugh now if I scrap it, but we'll try and do it together. It's quite a simple operation. Obviously I've set my length already. I've used my measuring stick here to decide that's 100mm, that one's 125, so I have to use quite a thin parting tool to get the length correct, because obviously we don't want to lose too much material. So fire that up. Right, okay. Just get the measuring stick, make sure the stop hasn't moved. Oh, 2.2. I've got another lap to do yet, crikey. I've no nerves left. Right, in again. I'm getting the microphone cable tangled up in the handle. Right, we should be at full depth now. Now the engineers amongst you will have heard the tone change just as we got to full depth. Let's just check I've got my measurements right. 4.73, ooh, we're pretty close. So what I'll do now is, off camera, is I'll take this out of the chuck, or off the spigot that I've made. We'll go over here, and then I just run a hacksaw through it on the last bit. So that gives us our 2 liners. And then we can get on with putting these back in again, and we'll top turn them, etc., ready to go in the block. Okay, I thought we'd have a bit of an update on the liner job. So this is the last of the 4 liners to be rough cut. I put my mark in there, which is where I'm going to go to the top hat. I do that first so that I've got something to work to. These 3 liners have been rough cut, ready for finish cut. Now I do the finish cut, which will be about 10th thou next, but what I do first, I let all the liners cool down, because put so much heat into them, machining them, that if we tried to turn them to the finished size while they were hot, they'd shrink, we wouldn't get the correct pinch on the liner when it went in the block, etc. So we get everything to room temperature. So what I'll do now is I'll machine this last liner, and then we'll let it cool down, have a cup of tea, and come back to it. Now what I was going to say was, for those that are interested, regards turning cast iron likes to be, it doesn't like to be a tickle cut. You like, you know, with a carbide like this, you like to get a good cut on it. Not too much speed, not too much feed, but a good size cut. Now if you look, you'll see I've got like a 4mm cut on there, so 8mm in total. And I'm just going to go in one pass straight along. Now I am running it quite fast. I'm running it at 370, which is quite fast for iron, but I have to run it that fast because a bit like a race engine, if you want to transmit lots of, if you want to put a big load on, we have to put lots of revolutions into it so that it's got the torque to be able to, it's only on a friction drive there, to be able to cut. If we tried this at, say, I don't know, 125 revolutions, at that sort of depth of cut and that much load on the tip, what we'd find is a situation where the liner would spin on the index there. So by travelling faster, we're able to transmit more energy into the cylinder, and it will cut no problem. So I've got it on a real slow feed rate, and relatively fast, big cut. So I thought we'll start this together and see what happens. Beautiful. I'll leave that to cook. I'll get the kettle on. Right, we've finished machining the liners now. This was the last one to be done. So I just thought I'd show you something I found quite interesting. You know, we always go on about the difference of expansion rates, different materials, etc. Well, because this index hub that I turned initially for the liner to sit on is made of aluminium, and obviously the liner is iron. What we found is that obviously I made it so it just pushed over nicely when it was cold. Now that it's hot, I literally cannot get the it's too hot for me to even handle, and I've made a cup of tea. Wow. So yeah, it's the expansion rate of this alley is greater than the iron, so you can actually see where it's grabbed it inside there. Amazing. So that's the liners done. We'll put this over here with the block to cool down, and then we'll finish turning them, and then we can do some measurements then and get some pistons and rods in, etc. But for now, we're going to see how the ultrasonic cleaner is done with the carburetors. Right, I've had an old friend call at the workshop, and he's dropped off a CVH head. He wants some valve guard oil seals put in it. Bit of a skim, bit of a decoke with some other parts there. He's asked me to blast them as well. Box of treasure there. The old that's the bottom of an old Bosch cage electronic unit. Crossover pipe and CVH thermostat housing. So we'll get all that in a blaster and make it look pretty. Craig, just come here a sec, mate. Have you got any pictures of your car on your phone? I've got you on Shrigleytubetv, mate. Right, come on, show me a picture. Craig's restoring an RS Turbo, and he's probably the reason why I'm into RSs, because years ago he used to run actually at this site, wasn't it? Was it called G&L Performance? Yeah. G&L Performance. So I don't think any of your customers will be on here, mate, don't worry. Come on, shape yourself. Not prepped very well. So tell us about his car, mate. How long have you been doing it for? Is it a couple of years?
4 years.
4 years, look at that. Oh, she's a minter. What colour's she going?
Red.
What, sunburst?
Radiant.
Radiant. And you've got a turbo motor for it?
Yep.
Crikey, have you done a lot of welding on that or what?
Oh yeah.
Wow.
Loads. 4 panels. Sills.
Oh, hang on, there's a microphone. Right.
Really?
So when's it going to be finished for?
No idea.
Does your missus and kids love it?
No.
Right.
They think it's a money pit.
A money pit? All cars are money pit. That's the whole point of them.
I know, yeah.
Well,
We'll paint it next month.
Is it? Will you bring it down here for us to have a look at it when you finish it? We do love our Fords on this channel, you know.
No problem.
Excellent. Right, thanks, Craig. I'll get these bits blasted up for you, and then we'll go from there. Congratulations if you're still awake, and finish your popcorn off. I'll look forward to seeing you all next Sunday at 7. Hopefully, have a great week. Bye for now.